Quartz Composer, we had also the opportunity to make a plugin of all that stuff very easy. And one of these tools we made use of was VDMX. It's a software that's not very popular because it's for a very, very vertical niche market for VJs. And Falk, I already mentioned, he did the live VJing on the building. In order to do that, he was actually networked with the building, so we just threw an Ethernet cable out on Nathan Phillips Square, connected it to his laptop, and he was running the software with this plugin. So the VJ software was actually not producing a real video output, but instead was actually directly producing Blinking Lights protocol. With no barrier, no separate processes, just like the one tool did it. So here, the live preview here, and was in control of all these little details, and that's why it looks so good. Because he's really in control, he can adjust the contrast and all that stuff, the mixing. So this was in sync with the Blinking Lights Symphony. It's called the Stereo Love VJ set, and there are recordings on the internet. I yet have to post them on blinklights.net, but I will soon. And yeah, that really worked well. If you're on the Mac and programming, Quartz Composer is really a technology to look at. So this live interaction really made an impression. It was a much, much, much stronger visual presence than you have with pre-made movies. But it was visual in many ways. Here, this is the command center. This is the statistics overview on what's actually going on, the live view on the flow of data called the BMix. So there were multiple sources, like playback of a video, some kind of real-time source as the VDMX program that I just showed you. And lots of parameters, little stuff, all these details I don't want to really get into. Opacity, you can control these, they were all layered, and then you could say like, okay, if something is being shown on this layer, it casts a shadow on the other layer. So that's how we did the situation that you have a background movie going on, showing something, and when somebody calls in and plays a game, you can still see the animation underneath, but you have the game being superimposed on top of it. So it was all one mix, while before we always had like either it's animations or it's games or whatever. And now we could control all these. So there was a cool real-time preview visualizer. So when you were sitting in front of these huge screens we had, you were basically knowing what was going on, so it was much easier to debug if something was going wrong. And also tied into this new system was, as I already mentioned, VoIP, the Asterisk-based telephone control. So all the game control was going over that interface directly into our system. And worth noting, is 100% pure Java, which makes extending it pretty easy. Here you can see that setup. A couple of other utilities and hacks. Of course, we had a new designed games API because the whole platform was new. We had on top of this telephone controlled slideshows, which is a very neat feature we need, because when the press comes at like, oh yeah, I want to take some photographs at only half an hour time, how can we do this? We just prepare a couple of imagery, and then we give them a telephone number, and then they can just switch through a slideshow themselves, take their photos and go. Otherwise, they keep bugging you for hours. Somebody did an integration into the processing programming language, with a visual programming language that's in use by artists that create a lot of new, interesting animations. And of course, this Quartz Composer could be used for content creation as well. So we had an editing suite out there, and people could just take Quartz Composer, connect the dots and all the lines, and do animation. So this generative, creative approach, that was something we felt was necessary because the sheer size of the building ruled out what happened here with Blinking Lights. 144 pixels, 8x18, monochrome, means people really spend a lot of time on designing and handcrafting each single image of each animation. While with such a huge screen where you can't even see all the pixels at the same time, it doesn't work like this. You could also use these plugins and just, on a Mac, fire this up, use your camera as an input source, and then you could say, hi, and you're live on screen. So that was nice to do. And we also had a movie submission interface, this time on the website, so we didn't have to spend so much time sorting out emails with all these movies. On the lower part, below all that creative network-related stuff, we felt the urge to redo the way we control our lights. Because, well, wires are your friend. That's true. If you connect something and it fits, data flows, sun is shining, everything is fine. The problem is, it really, really takes a lot of time to take care of all of your friends if you have so many as we would have wiring that building. 960 lamps means like a shitload of cables, like 4 or 8 or whatever, how much you need. And it's not only the wires, it's like connecting them, screws and stuff. So you can literally screw it up really badly. So wireless comes in and says, hello, it's me. I'm your new friend now. No wires, no screw-ups. But sometimes, it's not that easy, although you really, really want. So it was suspense, it was really, we were looking for a lot of exit strategies along this process because we designed it, we built it, we shipped it, we set it up, we switched it on, and it didn't work. I wouldn't say it didn't work at all. Actually, it did a lot of very, very interesting things, all at the same time. And it was funny, while we were watching it, it was not clear what was actually going on and what action did, So there were a couple of floors that just worked. Especially the first one we set up in our own working floor. Yeah. So we switched it on and it was like perfect. Like, hey, yeah, another 30 and we're done. And then we set them all up, switched it on. It's like one was doing this and the other was doing like this. And depending on what the other floors were actually doing, floors changed their behavior all the time. Let me explain what the system was. So, we got this little box here with this funny sticker on it with tons of legal blurb that this is now an officially certified device and you can touch it. It's got this little antenna and was directly connected to the lamp. And then we had another wireless device, a controller, one per floor. So the idea was that we interconnect everything over an Ethernet-based infrastructure. So we laid out cables just to interconnect the floors, put them into the WMCU, which then talks to the lamps. Something like, hi lamp, it's me, your controller. You can trust me. And my number is, and you are now my lamp. And I give you an ID. And from here on, you're just listening to me. And then the lamp says like, okay. And we send data, what to show, and how to do it, to the lamp, and then we expect the lamp just to follow the rules. So we had this idea of central configuration and calibration. All we needed to do was to collect the IDs of all the lamps. However, 960 lamps is a lot, and you put them just out of the box and you have no clue what the ID is. But we were thinking about this before, so we put up a barcode. So once we've set them up, we could just walk through lamp by lamp, on floor by floor, collecting all the ideas, and so then we knew which lamp was. We put it all in the database, and then the WMCU tried to talk to the lamps and tell them what to do. And, you know, we had dreams, dynamic gamma calibration, or whatever we could do. In the end, we needed to go through some really hardcore debugging sessions. Actually, it was 2 guys doing a real hardcore debugging session, which went on for around 24 hours, 1 in Toronto, 1 in Berlin, and everyone was working like 3 hours on something, then falling asleep, turning over the results to the one in the other city, which then worked on it for another 3 or 4 hours, and this went ping-pong between Toronto and Berlin for a day, and then they finally debugged it. I don't really want to go into the details of all the bugs, but it was like a lot of it. And most of it were related to this basic assumption that a device you just have to tell them what they do and they will. Yeah, you really have to tell these lamps all the time what they're doing. It's not like, could you bring me coffee? It's more like, I want a coffee, I want a coffee, I want a coffee, I still have no coffee, I still have no coffee, 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 coffee. And then it works. So we put it on Ease the Stress. And it was really a bad day for control flicks. The resulting system was just pure chaos. All these matrix controllers were sending at the same time on the same frequency. Everybody was ignoring each other. They were all competing and fighting for the airwaves and the spectrum available, no prisoners. And the funny thing is, this burst mode of sending out data worked, while everything else had just too many assumptions and expected too much good behavior. Of course, you had to deal with a lot of things like reflections and shadowing and so on. In the end, it was still offices, and people were working there, not in the night, but they have like put up their stuff and cardboards, and I don't know, put up their own wireless equipment. I don't know how many Bluetooth devices they had. So that's a problem. So in the end, we came up with a refreshingly stable operation 1 week before we had to switch everything on. There's still some kind of Alzheimer's syndrome that lamps forgetting who they are. I don't know, it's like, so if you see missing pixels, it's basically a deluded lamp that just doesn't know, like, So, let me show you another video that was actually done in Canada. Am I still in time? Oh, I'm far ahead. Daily Planet is a show on Discovery Channel. Discovery Channel Canada is probably not the same Discovery Channel as in the US, but related. And they do stuff on technology. And we were very surprised to hear that they wanted to do a production on us even before we started. So they just came to us and said, like, here, we want to do something. And the results are very pleasing, and it's more about the technology, so you will see how everything worked out. Can we dim the lights and turn up the sound a bit more, please?
A team of computer hackers commandeers Toronto's iconic City Hall, and the authorities don't mind. Calling themselves Project Blinkenlights, the Berlin-based group turns the building into a giant video display. They unveil it during Nuit Blanche, an all-night arts festival. Thousands flock to check it out. In fact, they get right into it.
The idea of Blinkenlights is to turn the building into a display that can be used by anybody. In the normal mode, it just displays various animations. There's a playlist of movies and just plays back one after the other. But the real funny part is that you can actually play games on the building. So you just take your mobile phone, call a number, and at that moment the display, the building, shows a game which you can command and control just using the keypad of your telephone. I've got 28.
Each of the 960 windows becomes a single pixel in a giant video screen. They call the display the stereoscope because it takes advantage of the two curved towers' unique design. It's a huge project, 5 months in the planning, and more ambitious than the group's previous efforts in Berlin and Paris.
Project Blinkenlights is a group of gifted